Hello, and we are back. We're going to be looking at arithmetic series today. This is an arithmetic sequence, but series implies adding up a sequence. That's what series means, okay? So we have this arithmetic sequence here. What is the common difference here? What is D? Yeah, it's negative 10 each time. We're adding negative 10 to get to the next thing. So we have D equals negative 10, okay? And U sub 1, of course, is the first term. That's going to be 55, okay? Now, to find the sum of the first 12 terms here, we have to actually find what is the 12th term, or U sub 12, okay? So that means we need to find the general term here. Remember that to find the general term, you may have your own way. I like to find the 0th term. This is the first, this is the second, this is the third term. The 0th term would be the one that would be before this. In this case, it would be 65, okay? And so that means the general term is going to be D, negative 10 times n, and then plus the 0th term, 65, okay? That's where that comes from. All right, so that's the general term. We can find then the 12th term by plugging 12 in for n here, okay? So we have negative 10 times 12 plus 65, right? So that's negative 120 plus 65, so that is negative 55. Does it make sense that it's a negative number? Well, let's take a look at this. It's going down. Yeah, it does, because eventually it's going to get it into the negative numbers. All right, so that's the 12th term. Now we need the sum of the 12th term. To find the sum, okay, all right, the sum, that's going to get us, let's see here, we're going to have to use this formula. It's really easy formula to memorize if you have to, but if you're in IB Math Studies, it is in the formula packet. Okay, the sum of n terms is going to be however the number of terms over 2, so half the number of terms, times the first term plus the last term. That's all it is, okay? So we already have the first term here, we have the last term, and we know the number of terms. So we just have to plug that in. It's actually pretty straightforward. So the sum in this case is going to be 12 over 2, that's the number of terms, the first term, and then the last term, right? Okay, so in this case, and this is kind of a funny case, I guess, this is, oh boy, what have I done with my pens here? Okay, this is going to be 6 times, but this is 0, so the sum is actually 0, which makes sense. It starts at 55, ends at negative 55 with all the integers in between. It's going to actually add up to 0. Okay, so why don't you try one, okay, where you have, what is the sum of the first 19 terms? The first 19 terms of this sequence here could also be called a series because we're talking about sum. All right, so go ahead and pause the video, give it a shot, and push play when you're ready to see the answer again. Okay, go ahead and pause. Okay, I hope that you were able to get here. We found the general term here, and then found the 19th term, plugged it into the formula. I got 893, okay? There's one other concept that I want to show you here, and that is if we have a sum in the first and last term, and we want to know how many terms there are, but it looks like my document doesn't have any more pages. Pause for just a second and I'll fix that. Okay, we're back. So we're looking at the sum of a certain number of terms of an arithmetic sequence is 1085.5. The first term is 23 and the last term is 60.5. How many terms are there? So we know that in this case, right, the first term, 23, the last term, 60.5. We don't know what this n is, how many terms, that's n, right? But we do know the sum of n is n over 2 times the first term plus the last term. We also know that that is 1085.5. So now we just need to find this n, right? This equals this. We can ignore this part, okay? So that means it's n over 2 times, in this case, 60.5 plus 23 is 83.5, right? So we want to get rid of this divide by 2. What do we do to, what's the opposite of divide by 2 to both sides? Let's multiply both sides by 2, and then we just have 83.5 times n, or 83.5n equals this times 2, right? So that's going to be 2,171, okay? And then we divide both sides by 83.5, and we get n equals, in this case, 26, okay? Now, you're going to try one of these. It's actually pretty straightforward. The point is you're solving now for n, not for the sum. But you want to know what n is. How many terms are there? Okay, so the sum of a certain number of terms is negative 70. First term is 43, the last term is negative 90. How many terms are there? Go ahead and give this a shot. Pause the video right now and try it. Pause now. Okay, so it was worked out, plugged it into the formula, ended up being the 20th term. There are 20 terms in this series, is what it's called, because we're adding up sequences. I hope that was helpful, and we will see you next time. Toodles.